Observe this picture closely. Here you will find that a traveler is traveling through the desert. Now in front of her, there is a tree, as you can see. Now even though there is no water or pool nearby, the traveler finds that she is able to see some sort of a watery or a shimmery reflection of the tree in the ground of the desert. Now we know that there is no water in a desert, so obviously the question of a pool in the desert is completely ruled out. So how is the traveler able to see this watery reflection or the watery image of this tree? Let us find out the mystery behind this. Now before we talk about that, let us revisit some old concepts. We know that when a ray of light is incident from a rarer medium, that is air, on a denser medium, that is glass, at the air-glass interface, refraction occurs due to change in medium. Now the angle of incidence in this case is given by I. Due to refraction, the light ray bends towards the normal. In other words, refracted ray BC bends towards the normal. Here, R is the angle of refraction. Similarly, when a light ray is incident from a denser medium, that is glass, to a rarer medium, that is air, at the glass-air interface, refraction occurs again because there is a change in medium. Now here, the angle of incidence is I inside glass, and the angle of refraction is R. Now notice that since the light ray is traveling from a denser medium to a rarer medium, refraction occurs and the refracted ray BA bends away from the normal, or it is shifted away from the normal. Now let us take a look at a very interesting video. In this video, simple apparatus is taken, a semicircular glass slab and a device which produces a parallel beam of light. Now you will notice when the beam of light is incident on the curved surface of the semicircular glass slab, at that interface, the air glass interface, it is incident normally. So no refraction occurs at the curved part. But on the straight part of the semicircular glass slab, you will observe that refraction takes place and the path of the light beam is bending. Observe that as you are increasing the angle of incidence, the angle of refraction keeps on increasing gradually. Now a time comes for a particular angle of incidence when the refracted ray leaves the glass slab along the surface of the glass slab, as you can see. And if we increase the angle of incidence beyond this point, we will find that the glass slab is no longer refracting the beam. The beam is undergoing reflection, obeying the laws of reflection. That is, the angle of incidence is equal to the angle of reflection. So what exactly is happening over here? Why is no refraction taking place even though there is a clear change of medium from going to the glass slab into air medium? Let us find out the mystery behind this occurrence. Now notice this diagram closely. Over here, a light ray is incident from a denser medium to a rarer medium. In this case, from glass to air. Now you know that when a light ray is incident at the glass-air interface, refraction occurs. This refraction occurs and the refracted ray bends away from the normal. Now the angle of incidence in this case is angle I and the angle of refraction is angle R. Now what happens if we go on increasing the value of I? Let us find out. If we go on increasing the value of I, a time will come when the angle of refraction, that is R, becomes equal to 90 degrees. In other words, here you can see that for a ray that is incident on the glass air interface from glass, the refracted ray is leaving parallel to the interface, or in other words, it is leaving along the interface. Now what happens if we increase the angle of incidence beyond this point? You will also notice one thing, that this angle of incidence for which the angle of refraction is equal to 90 degrees is known as the critical angle. The critical angle is denoted by IC. So we increase the angle of incidence beyond IC. Now when we have increased the angle of incidence beyond IC, we find that refraction is no longer taking place. The ray is getting reflected inside totally. So the phenomenon where an incident ray that is incident on the glass air interface does not undergo refraction but undergoes reflection is known as total internal reflection. Why is it called total internal reflection? It is called total internal reflection because no part of the incident ray moves outside. The entire part of it is reflected within the medium. Now, after our discussion, we can conclude two things about total internal reflection. What are those two things? Those are the conditions we need for total internal reflection. The first condition is light must travel from a denser medium to a rarer medium. That is, as we saw in the case of the video demonstration, light was traveling from glass to air. So it must travel from an optically denser to an optically rarer medium. And also, as we saw, the angle of incidence must be greater than a particular value. This value is known as the critical angle. So the angle of incidence, that is I, should be greater than IC, that is constant for a given pair of media. Now let us get back to the mystery of the traveler and the pool that she was seeing along with the reflection of the tree. Now in a desert on a very, very hot day, you know that the layers of air that are close to the surface of the earth are very hot. And as we move upwards, the temperature decreases. That is, if we move to a certain height above the surface of the earth, the air over there is quite cold. So if we move from top to bottom, the temperature of these layers of air is increasing. It is becoming gradually hotter. So you know that when air is hot, it is less dense, and when air is cold, it is more dense. Now let's see what is happening. When light rays are incident from the tree, as you can see by the blue arrow over here, it is incident at this particular layer. Now this layer has a temperature that is lesser than the layer below it. In other words, this layer has a temperature higher than this layer. So obviously, the lower layer will have a lesser density than the upper layer. And what have we studied about light ray traveling from a denser medium to a rarer medium? We have seen that it bends away from the normal. So refraction takes place at this point and the ray bends away from the normal. The same thing happens for the next layer of air. Here, this layer is at a temperature that is lower than this layer. So what do you think happens? Refraction takes place again and the refracted ray bends away from the normal, as you can see from the ray diagram. Now you will notice that every time refraction is taking place, the angle of incidence, that is I, is going on increasing. That is, through successive refractions in successive layers of air, the angle of incidence is going on increasing. Now the light ray keeps traveling downwards towards the surface. Now at a particular layer of air, what happens is this angle of incidence exceeds the critical angle for air. What happens is here the angle of incidence exceeds the critical angle. Why? Because the angle of incidence went on increasing through successive layers as the ray came down. So what happens? Total internal reflection takes place. Now are the two conditions satisfied? We saw that the angle is more than the angle, critical angle, and we also see that the light rays are incident from a denser medium to a rarer medium, because the air at the top is denser than air at the bottom. So total internal reflection takes place, and this light ray travels to the traveler's eyes. Now the traveler's eyes obviously will not be able to trace out this zigzag path that the light ray has taken. So the traveler's eyes will perceive it as coming from a straight path. So the traveler's eyes extrapolates the refracted, or in this case the totally internally reflected light ray. And after extrapolation, as you can see, the traveler is able to see the image of the tree on the surface of the earth. And it is due to this reason that to the traveler, she sees in front of her a watery sort of an image. This sort of an image which the traveler is seeing in the desert is known as a mirage. It is known as a mirage. So taking a quick recap, what did we learn? We learned that for a given pair of media, when light is traveling from the optically denser medium to the optically rarer medium, there is a particular angle known as the critical angle, beyond which, if the light ray is incident, total internal reflection takes place. What is critical angle? Critical angle is the angle at which, when the light ray is incident, the refracted ray forms an angle of 90 degrees with the normal. And as we saw, in that circumstance, the refracted ray left the medium parallelly with the surface or the interface. We also learned the two conditions for total internal reflection. What were those two conditions? Those two conditions were that light must travel from an optically denser to an optically rarer medium, and the second condition was that the angle of incidence should be greater than the critical angle.